In today's video, we're going to find a line of best fit and use it to make predictions. For this level of mathematics, this isn't totally the line of best fit. We're going to call it a line of pretty good fit or good enough fit. You're trying to find a line that looks good enough where you can make some predictions with it. So we're going to take some data. This is some data that I borrowed from another teacher. If you're a student in my class, then you have access to that teacher's video as well. And this data compares height in inches with a person's quote unquote wingspan in inches, or you can think of it as their arm span. So that is the distance from fingertip to fingertip when they hold their arms out. So this distance, you can think of a little kid going, I love you this much. That's your wingspan or your arm span. So we're going to draw a scatter plot. You've already learned how to do this, but we're just going to review how to do it so that you label and scale the axes appropriately. So I have highlighted here my highest and lowest numbers in both of my columns. And usually my X is the value on the left and my Y is the value on the right. So my X values need to go between 68 and 74 because that's, not 68. Sorry about that. It's 58 is the lowest. 58 and 74 and 58 and 70. So they need to cover those. You could make it so that this graph starts from 0, but for this graph, we want to be able to see all the points really well. So I'm going to do what's called a broken axis. A lot of graphs don't actually do this to tell you that they started somewhere other than 0. So you have to be careful when you're looking. Make sure to look where they start their graphs. Now on my X, I want to go from 58 to 74, and it needs to be scaled so that all the numbers go up at the same rate. This line does not make any sense if your numbers are going up at different values. I've had students just go down and just label their axes 62, 73, 70, 62, which doesn't do you any good. It doesn't show you where anything is. So we're going to go through and start, we want to make sure that we include 58 and we include 74. So the difference between 58 and 74 is 16. So I want my gap to spread at least 16 big. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 squares to work with. And I'm just thinking 9 times 2 is 18, so that'll work. Now you may think, I should just divide 16 by 9. Well, that's going to give you a fraction. It's not very pretty. And even if it weren't a fraction, if it ended up being like a number, say like 3, it's really hard to figure out like what the middle of 3 is when you're graphing. So do numbers you know how to work with. I'm going to use 2's, going up by 2's. So that'll give me 18. And I'm going to start with 58. Well, actually, I'm going to start with 56, so I have a little bit of wiggle room on the back end. So I'm going to start with 56 and go up by 2's here. 60, 62. Okay, so I just got to 74. It's going to go that big. And make sure to label your axis with both what it's measuring and what it's measured in. So it's height in inches. Now on the other side, it's 58 to 70, and I have 1, 2, 3, 4, 5, 6, 7, 8 squares. So I have 8 squares to work with. I think it'll be nice to just work with 2's again, because 8 times 2 is 16. That'll more than cover it. And I'll start with 56 again, just so that this one kind of looks the same as the other one. So 56, 58, 60, 62, and be sure to label it. I'm going to label it as wingspan in inches. Okay, now we're going to plot all of our points. Remember, you need to keep in mind how big your space is that your square is covering. My squares are covering too big. So if it is an odd number, it's going to be in the middle of a box. All right, so 62, 61, 62, 61. 1 is right in between 0 and 2. So I did that one. 63, 64. 63 to 64. It's going to be in the middle. So that's why you want numbers that are easy to work with. If I were going up by threes, this would be way harder. And then 70, 69. Okay, so I have a graph where I already did all this because it's kind of boring to watch me do the whole thing. So here's the graph that I already did. And voila, this is actually not what we're learning. We already learned how to do a scatter plot, but you do need to know how to do a scatter plot in case you need to do a scatter plot and draw a line of best fit for your own data. Now, we need to find the linear equation of the line of best fit. And this is a review from a few units back. The linear equation that we learned is called slope-intercept form. It's written as y equals mx plus b. If this does not sound familiar to you, or it only sounds vaguely familiar, I recommend that you check out my video where I talk about y equals mx plus b and how to find the equation to ring a bell in your head. In this equation, m is slope and b is y-intercept. And for our line of best fit, we're going to find both of those. But first, let's draw our line of best fit and find out what that equation is. So step 2 is draw a line of best fit on the graph. How do you draw a line? Those points are not in a line. So we just want a line that kind of goes through the middle. And as you've been thinking about predictions or thinking about whether or not it has positive or negative correlation, you've kind of been drawing your finger in a line. So we're going to draw our pencil in a line and try and I would put a ruler and test some out originally so that you can figure out what will be the best line. So I'm going to draw my line. Let's do... Okay, here's my line. I figured out how to make it automatically straighten, which is kind of nice. Okay, so when we learned how to find an equation from a graph, we learned to find the y-intercept by looking where it intersects on the graph, where it intersects with the y-axis. Here's our problem. It doesn't. It does, but it's in somewhere in the space between 0 and 56, which is not very helpful, right? So we have to use the equation methods of finding y equals mx plus b in order to make this way work. So I'm going to pick 2 points on the line. They should be as pretty as possible. I see this one right here and this one right here. So I'm going to use those 2 points and I'm going to find their slope. Remember that slope is the m, right? And we learned it as change in y over change in x, or this formula, y2 minus y1 over x2 minus x1. I'm going to show it both ways real quick. Be careful on your change in y over change in x, because this scale, how you scale it is going to change what each square equals. So you need to be careful how much it's changing. So I'm going to go from this point to this point. So I'm going to go up and then go over. So here's my rise, my change in y. It went up and it went up 1, 2, 3, 4, 5, 6 squares, but it didn't go up 6. It went up from 58 to 70. And 58 to 70 is actually plus 12. So you have to be careful if you're doing this on the graph. It's going to be 12. And then as we go from here to here, it went 1, 2, 3, 4, 5, 6, 7 squares. And 7 squares, it's going up by 2, so that's going to be 14. And then simplify your fraction and we get 6/7, which is kind of an ugly slope. A lot of your lines of best fit are going to have an ugly slope. Hate to break it to you. Then let's do the formula way. So that's the way to do it with rise over run, or change in y over change in x. It actually involves a little more math than it did before. You can't just count the squares. So I'm going to take those points and take their coordinates. That point I know from my table. It's 58, 58. And I'm going to the point over there. Is 72, 70 a point? 72, 70. It is. It's right there. So 72, 70. Now, these points do not have to be in your data set. You could just say, I want a pretty point that's on this line. There isn't one right there. And then you could use that point and decide what that point is. That's okay. You just got to make sure that it's on the line you drew. So 72, 70 is the one. Now we're going to use this formula. To do this formula, you're going to put XY, XY, and just choose one of these to be the first one. I'm going to choose this one to be first and this one to be second. And that way my bigger numbers will be my 2's. They'll be subtracting, so I won't have any negatives. Okay, we'll just put into our formula Y2 minus Y1 over X2 minus X1. And I get 70 minus 58, which is 12. Well, let's erase these so we can keep working. 12 over 14. I got the same thing. Yay! Okay, it says explain what the slope means in the context of this situation. This is where it helps to think of it as change in y over change in x. So this is 6 over 7. So change in y is the change in, our y is wingspan, and our x is inches. So we're going to say that change in y, we go up 6 inches in wingspan, because that's our y quantity, for every 7 inches in height. Or you can say 6 inches in wingspan for every 7 inches in height. So 6, you're just going to say 6y for every 7x. Now, we need to find the y-intercept of our line. Just like I said before, you can't find it on the squiggle. So we're going to use the equation form, y equals mx plus b. And we want to solve for b. So I need to plug in stuff for m, x, and y. We've just found m. It's 6/7. So I'm going to find x and y. This might not turn out pretty. I haven't done it yet. So we're going to see. I am going to pick, it's going to be one of those 2 points that I know is on the line. So let's just do 58 and 58, because then I don't have to keep track of which is which. So plug in your x and y into the equation. And now we're going to find out what this is and solve for b. So on my next step, it's going to be 58 equals, what's 6/7 times 58? So I need my calculator. And we're going to do 6/7, 6 divided by 7. And then I'm going to do times 58. Is 49.7. I'm going to do 49.71. So 49.71 plus b. Now we're going to find out what b is by just subtracting 49.71 from both sides. It added, so we're going to do the opposite to get b alone. I don't know what 58 minus that is. So we're going to hit enter, and 58 minus, do I have an answer on here? No, I'll just put 49.71. 8.29. So when I subtract, I got 8.29 equals b. Write an equation for the line of best fit using the slope and y-intercept. So now all you have to do when you're writing your equation, y and x can be anything. That's why we keep them as variables. So now I'm just going to keep my slope and my y-intercept like this. There we go. There's my equation. It's not pretty. Rarely are line of best fits pretty equations. They just aren't. It's real life data. So I'm going to use my equation to predict the height of someone who is 68 inches tall. I'm not going to do it for all of these. To do that, you should remember what your quantities of x and y were. X was height. So I have the height, so that means I'm going to plug this in my equation for x. And I want to find wingspan, which was y. So I'm going to take my equation, y equals 6/7 times x, and I need it for somebody who's 68 inches tall, plus, and then we need our b, which was 8.29. Now you might be like, wait a minute, did we have somebody who was 68 inches tall? Yeah, we did. We know how tall they are. Well, we're just saying, okay, according to my equation, I have a person who's 68 inches tall. How big about would I expect their wingspan to be? That's why we're using this equation. So let's find out what that equals so we can figure out what the wingspan is. 6/7 times 68. 6 divided by 7 times 68. And then plus, what was that number for our B? 8.29. Okay, I get 66.5757. We're going to say 66.6. And that's their wingspan. So their wingspan is 66.6 inches long. Okay, so now according to this, my wingspan is a little bit long. Why might that be? Well, let's look. I think my line of best fit was it's a little bit tall. So if you look, I have only 5 points above, and then I have 1, 2, 3, 4, 5, 6, 7 points below. So my line of best fit, remember this is a line of a good enough fit. My line of best fit doesn't totally fit the data the best, but it looks pretty good. So I'm going to keep this and say, yeah, it's pretty good. Because I looked at it and it appeared to fit the data pretty well. If I were to redo this one, I would probably go back and adjust it so that I had more points above the line, but that's okay. We're just trying to make it a good enough prediction for this point in our mathematical careers. So why do we call this a line of pretty good fit? Well, it's good enough, and we haven't figured out what the line is mathematically. Later on, you'll find out what the line is mathematically, and you'll be able to do it.